Hello everyone, today we're looking at Unit 3, Lesson 0. We're going to do some review of essential skills we need in order to start this algebra unit. So two things we're going to chat about in this note. First off, we're going to talk about our exponent rules in terms of when we have a power with the same base, what do we do with their exponents? And then we're also going to look at collecting like terms again, which we've seen in our past few units with linear systems and linear relations. How do we collect terms that are alike and making sure that we know that they're actually like terms. So let's start with our exponent rules. When you're multiplying powers with the same base, you're going to keep the base the same and you're going to add the exponents. So what I mean by that is this power has a base of a, and then we have some powers of m and n. So when we multiply them, what we'll do is we'll keep the base exactly the same, so the base would stay as a, and then our exponents will add together. Okay. When we're dividing two powers with the same base, again, we leave the base the same, but we subtract. So a to the power of m divided by a to the power of n is going to equal a to the power of m minus n. Sometimes, too, we can also see division written like this, where we have a to the power of m divided by a to the power of n, and the process is the same. We'll still end up with a to the power of m minus n. Okay, that's our quotient rule. The next rule is our power rule. So if you have a power that has an exponent and then it's being raised to another exponent, you're going to multiply those two things together. So we have a, again, we keep our base the same at a, but we have this exponent and then this power is being raised to another power. So we multiply those two things together. So let's try to apply some of these rules to some examples here. Our first example, we have x to the power of 3 times 3x times negative x to the power of 2. So some things to take note of are exponents. So we have an exponent of 3 here. Well, we don't have any exponent on our next bracket. So when there's no exponent, we can assume that there's an exponent of 1. Okay? So we have an exponent of 1 here, and we have an exponent of 2 here. When we simplify, we're going to multiply all of our coefficients together. So we have 1 times 3 times negative 2, that's going to be a negative 6. Okay, our variable part stays the same. We leave that alone. And then we need to add all of our exponents. So when you add those together, you should get 6. So remember, my exponents were 3, 1, and 2. Okay, so that's where that power of 6 came from. Let's try another one. This time we're dividing. So when we're dividing, remember, we're going to subtract our exponents. And once again, I'm just going to give this n here a power of 1 so that we remember that there is actually a number there we have to account for. So we'll divide our coefficients. So 18 divided by 6 is 3. And then we'll write our variables. They stay the same. But this time we're going to subtract our exponents. So 4 minus 2, we're going to have a power of 2. And then we'll have 5 minus 1, we'll have a power of 4 on that. Okay? We'll continue on to the next example. This next example is a power of a power. So when we have a power like this outside our brackets, we got to make sure we distribute it to everything inside our brackets. Remembering once again that this b has an exponent of 1 on it. Okay, so if I was going to rewrite this so that you could see the exponent being applied to each part, okay, we'd have a negative 2 to the power of 3. And then we'd have a, and remember, a power to a power means we're going to multiply them. So 3 times 3 can become 9. And then for b, again, we have a power of 1 raised to a power of 3. So 1 times 3 is 3. And then we can simplify that. Negative 2 to the power of 3 is a negative 8. So a to the power of 9, b to the power of 3. Okay, so sometimes we can have power rules within power rules. So for this next example, we're going to have to first deal with our exponents before we deal with any multiplication or division. Remember, we should be thinking about BEDMAS when we try to simplify. Whenever we're trying to simplify or calculate an expression, we always have to think about, okay, I have to do my brackets first, my exponents, then deal with any division and multiplication. So in this case, there's nothing to simplify within a bracket, so we can move to this exponent. We're going to have to apply this exponent to each part of what's inside this bracket. Okay, so let's do that. So a negative 3 squared is going to be a positive 9. And then on the x, we're going to multiply those exponents together. So x2 times 2 is going to be 4. And the same is true for my y. I have a y to the power of 1 times 2 is going to be 2. All right, I'm just going to rewrite my other brackets, and then we'll take a look at multiplying and dividing. Oh, in the denominator, we have an exponent as well we can distribute in. So we'll distribute this 3 to each part of what's inside my bracket. So 2 to the power of 3 is 8, and then we'll have x to the power of 3, and y, 3 times 3 for my exponents is going to be 9. Okay, from there I'm going to deal with the multiplication on top. So we're going to multiply our numbers together, so 9 times 8 is 72. Okay, and then in terms of our powers, if we're multiplying, remember we're going to add those exponents. So on my x's, I have a 4 plus 3. Right, on my x's, I have 4 plus 3. So that's going to add to 7. On my y's, I have 2 and I have 7. So I'm going to have to add those together. So 2 plus 7 is 9. And then I'm going to leave my denominator. And then that's the last thing we'll deal with. We'll deal with that division. Okay, so 72 divided by 8 is 9. Okay, and then on my x's, once again, if we're doing division, we're going to subtract those exponents. So if I have 7 minus 3, that's going to be an exponent of 4. And then my y's both have a power of 9. So we could write that, but we should hopefully see that those y's just cancel out. Okay, so that's your exponent laws. We'll have some practice with that on your practice problems today. Let's now take a look at simplifying, which this should really be review and some extra practice from our previous units. So remember, when you see simplify, what that really means is that means that we're going to collect like terms. So we have to look for any like terms and then add or subtract them together. Kind of follow through on whatever sign is there. So I have a positive 7x, I have a positive 2x, and I have I have a negative 4x. So 7 plus 2 is 9. 9 minus 4 is 5x. And then I have my constants here. I have a negative 5 and a negative 3. So that's going to be a negative 8. Okay, pause the video and see if you can try B on your own, and then we'll come back together and do C. Okay, so there's the solution when you combine your like terms. I just want to point out something too. When we're starting to write these terms and we have terms that have variables with different exponents on them, something that we've made a note of in past units is that we always want to write terms in decreasing order of exponent. So your highest term, your highest exponent on any given term will come first, and then it'll be decreasing from there. Okay, so you can see that on my first term I have an exponent of 2. On my second term, I don't have an exponent there, but we could say we have an exponent of 1, right? And then it continues to go on, basically until you have just a number, just a constant. Okay, let's look at C. So we need to first write this equation without our brackets. All right, so if there's no number, if it's just like a plus in front, then we can just rewrite the expression without the brackets. It doesn't change anything if we just rewrite if there's just a plus out front. But when we have a negative out front, like in this case, we do need to distribute that in our brackets before we just get rid of our brackets. So a negative distributed to an 8 is really a negative 1. So a negative 1 times 8 is a minus 8. And a negative 1 times 3x is a negative 3x. Okay, so from there, we'll just collect our like terms. So we have x plus 2x is 3x, minus 3x is 0. So we don't have any x's. Now if we look at our constants, we have a negative 5 minus 6 is a negative 11, minus 8 is a negative 19. Okay? So that's just when we're collecting like terms. Sometimes we might need to expand and then simplify. We're going to start with just expanding, and then we'll combine the two. So for expanding, we have our 6 outside our brackets. We're going to distribute that in to our brackets. and multiply those coefficients when we do, okay? So 6 times 3 is 18p. Okay, 6 times 5q squared is going to be 30q squared, right? Nothing changing with that variable or exponent. And then 6 times r is just 6r. Okay, the second example here, we do have a power. So we have to think about, if I'm multiplying something by a power, what are we going to do with those exponents? Remembering that this has an exponent of 1. All right, so let's distribute this in. So if we have 2x squared times everything inside this bracket. So 2 times 3 is going to be 6x, and then I have an exponent of 2 and 2. We're going to add those to get an exponent of 4. And we have 2x squared times a negative 7x, so that's going to be a negative 14x, and then we add those exponents of 2 and 1, we get 3. And then finally, 2x squared times a positive 8 is going to be a positive 16x squared. So in these examples, we just expanded. There was nothing to simplify because we don't have any like terms. But let's look at expanding and then simplifying if we have any like terms. So our first example here, we're going to again distribute what's outside the brackets inside a set of brackets. Okay, so the 2 is going to go inside that first set of brackets. And then we have this negative 3. Make sure that we carry that sign through. It's going to go on in that second set of brackets. So 2 times 4m is 8m. 2 times 5 is a positive 10. And then we'll have a negative 3 times 2 is a negative 6. And a negative 3 times a negative 6m is a positive 18m. Okay, so we've expanded. Now we're going to go ahead and collect those like terms. 8m plus 18m is 26m. And 10 minus 6 is a positive 4. Go ahead and try B on your own, remembering to think about what exponent law you're going to use when you expand and then simplify. Okay, there's the solution when you expand and simplify. Hopefully you see that there was a like term with your x squared terms that you could combine. So that's expanding and simplifying. That's all for your notes for today.